All right, now I'll start over. We are going to get into some more Python fun tonight. The first thing that I was surprised to see in our book was kind of a philosophy of Python. And if you ever get into philosophical debates on programming languages, there are people like me who are very religious about Python. And there's a zen behind Python. And a couple of the guiding principles here are that simple is better than complex. So the simpler your code is, the better it is. Complex is better than complicated. So if you're solving a complex problem, that's okay to have complex code, but complicated code that's not clear, is not the desired outcome. Readability of your Python is important, so readability counts. There should be one and preferably only one way to do it, it being whatever problem you're solving. And now is better than never. And going into life, that last one talks to me a lot. Procrastination sucks. Doubting yourself and not starting on something sucks. So now is better than never. So when it comes to coding, start writing code even if you don't know what the outcome's going to look like. So let's start with lists. In Python, lists are a collection of items in a particular order. So in other languages, you might have heard of arrays or vectors or any other structure like that. A list in Python is the same kind of thing. You can put anything you want into a list. So we talked last week that data types variables in Python are not typed. So you don't declare this is an integer, this is of class, whatever. Variables can point to any type at any point in time, and lists are not any different. So a list can hold anything, including other lists. It doesn't matter. It can hold anything. Lists are bound by brackets. So when we see the code syntax in a little bit, you'll see the brackets around it. And best practices, lists should be named something plural. Students, customers, deer. Okay. I make myself laugh, if nothing else. So when we come to writing our Python code, here's an example from the book. I don't start every example in here with the import logging and logging basic config equals log level debug, but I do want to get in the habit and stay in the habit of using the logging framework instead of just printing output. And so we're going to see this logging debug a lot in my code for class. When you look at the book, they'll be printing things, but I want to get out of that practice because what I was hoping to get to tonight, but we won't be. Next week we'll get into file processing, like putting data into and out of files. And in that case, you tend to use print or you tend to use a different way of doing it. But logging is always logging. So logging frameworks are good. So here I'm creating a list of bicycles. Can anyone tell me the data type of all the values in this list?
String.
They are all strings. Yep. So I have the open bracket to specify that I'm creating a new list. And in that list, will be these 4 elements, four data types, 4 things. The first, Trek, Cannondale, Redline, and Specialized. These are 4 bike manufacturers. Then the next line, I'm debugging, I'm printing out something quick, the length of bicycles being the array. %d is a placeholder in these logging debug things. And in that value, I'm going to put in whatever comes back from that length of bicycles. For right now, it doesn't really matter. And then I'm going to print out or debug bicycles itself, the array of bicycles, or bicycle manufacturers. Just a note so I didn't forget to say it. All of the code in this, when I'm doing log and debug, assumes that these 2 lines of code have been run. If they aren't, it won't work, or you won't see any output. So when I print it out, this is what happens in my application. So again, printing is a generic term, not always necessarily the print function. The book always uses a print function, but again, I'm not in that habit. Python returns a string representation of your list, including the brackets. So when you see these 3 arrows at the front, this is me using that interactive Python interpreter on my command line. Like I just wrote the words Python 3, pressed enter, and then I was in a interactive framework. So that's what this looks like. And then the output is on the next line. So my first line was that logging debug, length of bicycles is 4, because there are 4 items in that list. The next line was the logging debug of bicycles, and the output is that array with brackets and the 4 elements in that array. Pretty straightforward?
Yeah, it makes sense.
Now you'll see the strings are bound in string characters. If the items in the array were not strings, say they were integers, the value that was printed would not be bound in strings, bound in quotation marks. It would be just the number. Lists, you can access all of the elements in the list by its index. So if you think about the array or the list having 4 elements, each element can be accessed by its index. Index is 0, 1, 2, and 3. So as an example, logging debug bicycles 0. From the 0th element is Trek, because it is the first element in that list. Bicycles 1 is the second element in the list, Cannondale. And since the data in there is a string, I can apply string functions to it. If it was not a string, I could not apply string functions to it. But in this case it is, so I can call that title function we talked about last week, and the output is Trek capital T. It's super important to know that indexing starts at 0. So it might be a little confusing for me to say the 0th element or the first element when that means the same thing. All right. If you're not familiar with the acronym CRUD, it's used regularly in databases and data structures and stuff. It stands for create, read, update, and delete. So creating meaning putting things into the list, or creating the list itself. Reading means getting the items out of the list. Updating means changing whatever is in the list, and deleting means removing something from the list. So we're going to talk through how we make all these things happen. So this first line of code, motorcycles equals bracket Honda, Yamaha, Harley Davidson, bracket. Our list has those 3 elements in it when we print it out. Now I'm cheating a little bit here. In the interactive console, if you just type the variable name, the next line it will print out that variable name, or the contents of that variable. So you'll see motorcycles. If you actually run a Python program, like in a Python file, and you just have a variable name on a line of code, nothing will happen. But in this interactive one, it prints out the values. So again, I can access and modify or change the value, the first element, the 0th index. I'm changing it to be Ducati instead of Honda. So you can see then I print it out again, and the first element is Ducati. The others did not change. Elements at index 1 and 2, or the second and third elements, don't change. lists have a function append to add something at the end. So you'll see the first 3 elements in the list did not change. I appended Honda, and now Honda is at the end of my list. I might say I appended it at the right. I appended it at the end. I think more accurately, it is now the new highest indexed record in the list. So that's index would be index 3, or the 4th element. We're going to get through this real quick. But we have code to write, so it's going to be fun. So instead of creating a list with all the elements baked into it, we can start with an empty list, open and close brackets, and then we can just append the values we need to add to it. So you'll see using the append function, it will, if there's nothing in the list, then the newest first element would be Honda. And then the next line, since Honda already exists, the newest element is Yamaha. Then we append again to get Harley Davidson. And our list looks like that, in the order that things were inserted. And that's an important characteristic of lists to know about. I think in the definition it says it is an ordered set of elements. Ordered meaning the order in which things are inserted is remembered. There are other data types where the order in which things are inserted is not remembered. And so that is probably the thing that makes the list different, is that order is maintained. So we can also insert items into the list, not just at the end. We can insert it in the middle. So you'll see insert 2, and in the end, the newest that element, that Suzuki string, will now have the index of 2. So that's an important one as well. It's not the first, second, third. It's the index that you're specifying there. Reading the Slack about VCU website saying it's already downloaded and expired, won't let you re-download. When you say download through VCU, you mean the Windows license key? Oh, that's a pain. So somebody paid $15 for it. Somebody paid $4 for a pro license on eBay. I'm really surprised you can't re-download it from VCU. That's odd. But it seems like there are ways around it. All right. Deleting items from the list. So there's a magic Python keyword, DEL, to stand for delete. And if you'll notice in the code, it is not a function. So there's no parentheses around motorcycles 2. It is a keyword, DEL. What you're doing is deleting whatever is in that memory space, or in the list case, whatever's at that index. So here, you are deleting the item at index 2. So looking up at the list, Suzuki is at index 2. Interactive, do you mean terminal or command line when you type Python 3 to get to the 3 arrows? Yes, exactly right. And I'll show you that once we go through the slide some. So my list started Honda, Yamaha, Suzuki, Harley Davidson. I deleted index 2, which was Suzuki. So you can see now my list is Honda, Yamaha, Harley Davidson. Another function that is a little different, it's called pop. It is part of the list. Pop removes the last element from the list, so the highest index element. And the good thing here is that it returns the value. So I've assigned that popped value to a variable bike. We will explicitly talk about what data structure typically has the key or the function pop. It's a stack is the data structure. Not today, but as we move on, and so that'll be more familiar then. But just for now, know that pop removes the highest index from the list and returns it because it is a function call, unlike delete. So then I can look at the motorcycles list. When you assign a pop to a variable, it removes it. Yes, it does remove it from the list at the same time. And that's demonstrated here. So after I've popped it, Harley Davidson is no longer in the list. But since I assigned it to my variable bike, I can print out the value of bike and see Harley Davidson. Now, pop has an optional parameter, which is an index number. So you can actually pop any item out of the list by specifying the index. So if you wanted to pop out the first element, the element at index 0, you can do it by passing the number 0 to the pop function. And then you'll see when it was Honda and Yamaha, I pop out the first one because I passed the number 0, and all I'm left with is Yamaha, which was element the second element, or index 1. Now, I know I'm going quick over things like what's a function and not a function and function parameters, because my assumption, and I think you've had programming classes before, so I think that concept is familiar. If it is not, let me know and I can go into a little more detail. Whether you want to chat or just yell at me or whatever, let me know. But I'm assuming that you get the understanding or the concept of what a function is and what function parameters are. So when I popped out that 0 element, I assigned it to new bike, and new bike, when I print that out, is Honda. And the last function here that we're talking about is remove. So it's very similar to pop, except instead of passing in an index, you pass in a value. So in this case, I want to remove the last remaining element, which was the string value Yamaha. So I can call the remove function and pass in a value. In this case, I actually assigned it to a variable first, but I didn't have to do that. I could have hard-coded Yamaha here, but I put it in a variable. And then when I look down, now I have an empty list. So reading through this 10 lines of code and output, 12 lines of code and output, what I'm trying to do by printing out the list regularly is to kind of show what is actually happening as we're going through these lines of code. So I started with a list with 4 elements. I deleted one, I popped another one, popped a third one, and then removed the 4th one. So you'll see top to bottom, the list just gets smaller and smaller and smaller. So that's a format I go through regularly throughout the class, assuming after walking through it that you can go back and look at it and it makes sense to you. If you need me to be more explicit and maybe break it up into different lines or something, or would prefer that, just let me know and I'm happy to change the style a little bit. But this is a good skill to have if you ever have to look at somebody else's code. So a list is a ordered collection of elements. We can change that order. There are functions that we can do to permanently change the order. The list itself, here I've defined a list of car manufacturers, printing it out, and it has preserved the order that I put the elements in. Then I'm calling the sort function on it. After I have called a sort function, I print out the variable, and you can see it is now alphabetical order. That should lead to a question. I'm wondering if anybody's going to ask the question that that leads to. Say it again. Is it always alphabetical?
That's what it just did. It put it in alphabetical order, right?
Yep, that's what it did for strings. If there were numbers in there, it would sort them numerically. Is it a quick sort? I do not know the implementation behind the scenes. And this is the beauty of Python over C++. You don't have to know if it's a quick sort, a merge sort, a bubble sort, a whatever sort. We don't have to spend weeks and weeks and weeks building those sorting algorithms. We can just call a sort function and assume it is as efficient as it can be. That's why I love Python. But yeah, and then so if you had mixed elements in there, numbers and strings, I don't know what would happen. We could figure it out. If we had objects, if we had other lists in there, what would happen? I don't know, but we can figure it out. That's why I love computing. We can figure it out. We can also reverse sort it. So in the strings case, it'll be reverse alphabetical. Numerical, it'll be reverse numerical, highest to lowest instead of lowest to highest. But those are permanent sorts. They are changing the actual order of the items in the list. So if we started with if we look at this list, it's a pretty, I would say, random order, and we did a permanent sort or reverse sort, we could never get back to that original sort. It is a permanent, you could say, destructive sort. No worries, class is recorded. I hope everything's okay. Temporary sort. So if we don't want to destructively sort the list, we can use a few global functions. So if you're, again, familiar with object-oriented programming, when we call a function like sort, when we use the syntax of variable.sort, sort is a member function of the class of, in this case, list. But here, we are calling a global function sorted. It is not a member of the list class. It is just, it's a kind of a global namespace, high-level global function. Its parameter is the list. So if you've done any C programming, it's a little more like C, where it's the functions are defined and you pass the objects in, or you pass the data in. But that's what this looks like. So we have a sorted function in cars. Now, what this really does is it makes a new list, and it returns that new list. So using that interactive Python interpreter, I can just do sorted cars, and it'll print out the new sorted list. I can also assign it to a new variable. So in this, I called the sorted function a second time, and I assigned the return value to a new variable called sorted cars. Printed out sorted cars, and it's in alphabetical order. And then just to show that it is really not a destructive sort, I printed out the cars array, the cars list again, and it's in the original order. So does the difference between the permanent sort and the temporary sort resonate?
Yeah, for me it does.
It does for me too.
Okay. Can anyone come up with a reason you might do that? What if your original list was, say, a list of purchases at a store, or a list of your credit card transactions, Why is it important to maintain that original order?
So, like, order of purchases, you want to know where you went first and, like, the order of purchasing the items rather than just the alphabetical order.
Okay. So where you purchased first, yeah. So imagine I work for a major credit card company, because I do. Why would that major credit card company care the order of your purchases on your credit card? Or let's say the order of purchases on your debit card affecting your bank account?
I mean, the only thing I could think of was like if it was fraud or something. So like they could tell like if you were in one place and then like 20 minutes later your card was used in like New Jersey or somewhere, that they would be able to tell that there's like fraud.
Perfect. I think that's a fantastic example. In my head, it was much simpler just keeping a running balance of your account. But yeah, that's actually a really good real world use case of why ordering of things matters. When would I want a non-destructive temporary sort of that? Or what would be a reason I might do that?
For ease of like looking for transactions possibly.
Okay. How so?
Because you can, let's say you know that the transaction was at a certain place, you can alphabetically sort it or something like that, or you know it was a certain amount.
Okay, awesome, perfect. I could sort by name to see for a quick lookup where was my Starbucks 2/3 way down the list. Cool. Or what do you mean I spent $17,000 at Home Depot? Because it's the top item on my list because I sorted by transaction amount. Yeah, those are great uses of it. And then a couple of other things that are kind of functions for list, kind of behaviors of a list. I didn't want to make a new slide for all of them because I just wanted to show a bunch of code. So again, we'll start with our cars list. 4 elements. Cars.reverse. So I have a reverse function on the list class that I can reference, and it destructively changes the order of my list, and it just reverses it. To me, that implies there's a global reverse function as well. I'd have to look it up, but I bet you there is. That would be non-destructive and temporary, just like the other ones. I did this earlier, but you can call the length function passing in the list as a parameter. So again, this is not a length function on the list class, but again, it is a global function because the length, len, length function, can be used for all kinds of things. You can pass a string into it and get a string length. Any other data type, you can kind of get like an attribute of size related to it. So we have a length function. Now, we talked earlier about getting items by index. Anybody want to guess what index -1 is?
The last item in the list.
Yep, the last item in the list. So this one's a little trickier. The last item in the list is -1. The first item in the list is 0. We talked about that. This syntax, I am using the cars list and sending in the first index and the last index. What is returned from that? You can tell by looking at the second highlighted line I have, but what's different there? So does anybody see the difference there?
It includes the brackets.
Okay, so what does that imply?
That's the length of the list.
Like in between, what's in between? Ghost?
You are both close. If cars bracket 0 bracket returns a string Subaru, the item at element 0, or index 0 element 1, 0:1, what does it return? The return implies function, but it's not a function, so what is the value that you're getting on cars 0:1?
Is it like 0 to 1 but not including 1?
Uh-huh. Still touching close. There's one big thing that was touched on. Somebody said brackets. What are lists bound by?
Brackets.
Brackets. Is this bound by brackets?
Nope.
Is that a list?
Nope.
Is this a list?
Yeah, but it's one item.
It is. So when you use that syntax of 0:1, or it's really any index colon another index, you're getting I think it's another list. You're getting a subset of the original list as a list. So the next example is returning a multi-element list. It's got 2 items in it. But a list doesn't have to have elements in it. It can be an empty list. But here, somebody said exclusive or less than the second number. So yes, the syntax is from list cars, starting with the first index, up to but not including the third index. Those are the things I want back as another list. So I'm getting index 1, Audi. Well, I sorted it, sorry. Index 1, Toyota. Index 2, Audi, but not index 3. So it's an exclusive list for the second element. Starting at 1, up to, but not including 3. But the really important part about that is it's another list. So if I were doing operations on the return value, it would be a list. So I could again sort it, or I could again reverse it, etc. And then, like every other programming language, except C, because C sucks. No, I can try to access an element in the list that does not exist. So what is the maximum, what is the largest index of this list? If we start at 0, the largest one would be 3. And so when I try to reference index 55, I get an error. It says, the actual error message, index error is a type of error, list index out of range, meaning there is no item at index 55. It's not a large enough list. This traceback format is like a stack trace or a log from any language that has error handling. When we get more complex, this will help you find where exactly the error in your code is, or where it's coming from. But here, since I was using that interactive module, it's saying it's coming from the standard input line 1, because it's a single line command. But anyway, the actual error is index error, list index out of range. Cool. Nod. I can only see a couple of you, so. All right. Working with lists. lists are probably one of the data structures that you will use the most in your entire Python life. There are others like dictionaries and sets and tuples that we'll use, but and some of this applies to all of them, all collections, but lists you will see all the time. And so one of the most control. Okay, so we are going to talk about control now in our applications. Up until now, we've basically talked about variables and functions and how to access those variables, data types and whatnot. We're finally going to look at some code to actually do stuff with that data. So the first thing we're going to do is figure out how we can work with every item in a list. Example in the book, imagine you're programming a game and you're on kind of a time clock, and every tick of the clock you want to move every element on the screen. So if you made a multiplayer game or Pac-Man and you want to move all the ghosts 3 spaces every tick of the clock. Or maybe you want to print out today's stock market prices or list all your orders, verify inventory, whatever. This syntax might look familiar to you. You have a list of magicians, Alice, Pat, Pallaby, and Sam. We'll start with a counter or an X variable. We'll assign it to 0 because we usually always want to start with the beginning of a list. And we'll do a little while loop. While loops look a little different in Python than they do in other languages, but the concept is the same. There's no parentheses around things. Whoops. Shit. There it was. X is a variable, so while the variable is less than the length of magicians. So in this case, that len function would return a 4 because our length of the list is 4 items. And for each of those, we will print out the item at that index. So a magician's X, we'd start at 0, then we'd add 1 to be 1, 2, 3, all the while it's making sure we're within the bounds of that list. And so we've got a bunch of lines of code, and our output would be Alice, Pat, Pallaby, and Sam, just like the order we put them in our list. Python's fantastic. We don't have to do that. So we have a for loop, and I always make notes to myself that I think are funny in the slides. Like, I don't know why I showed you that last one, just to show you like there's a better way. So in Python we have a for loop, and with any collection, which is a data type that has more than one element in it, in this case we're dealing with a list, we can do a for loop in magicians. So for magician in magicians. So for every element, we will assign it to a variable magician in the list magicians. And then we can debug the magician to print it out. We don't have a counter. We're not checking the length. The iterator, enumerator, the iterator of magicians is just going to handle all that stuff behind the scenes. And so the output, and then I threw in another, I should have put a space in between there, sorry. Then I output done. So I'll see Alice, Pat, Pallaby, Sam, done. And the next line, I have a new magicians list with nothing in it. I can have the same magician's code, and it just won't do anything. Oops, I forgot to copy down the log and debug done, but still. There's nothing in the list, so nothing will be operated on in the list. So that for loop you're going to see all the time. All the time. Like every 4th line of Python code is pretty much a for loop. So does that syntax make sense? Any questions about how that works, why it matters, why the old way's not good? The old way's not bad, but this is better. Can you nest for loops? Absolutely. You can do nested for loops. You can do, yep, absolutely. So imagine I had multiple loops or multiple lists. I could nest a for loop in another for loop. And that's a very common practice or common pattern. Good question. And there are really other cool things we can do. And when we open a Python editor, I'll show you some other cool things. So there's a couple of pages in the book that talks about things you can screw up. And programming to me is one of the most fulfilling activities in the world because you make things happen. You make business value. You either make money or save money and all that kind of good stuff. But on the other side, programming is the most frustrating thing in the world because sometimes you have little errors that mess your program up. And so a couple of things that they list out in here, and I can show you examples of how to do this wrong. Indenting where you shouldn't, forgetting to indent where you should, and forgetting a semicolon. So I didn't explicitly say semicolon, but going back the slide, you'll see at the end of my for loop, I have a colon. Did I say semicolon? Whoops, I meant colon. So for magician and magicians, colon. When we talk about if, while, do, for, all those kind of looping constructs or control keywords always end in a colon, not a semicolon, never a semicolon. So this code would not work because I would not have a colon at the end of after magicians. So another magic function is range, and you can use range a lot when you're counting, making numerical lists. So let's say this is from the actual Python documentation. Rather than being a function, range is actually an immutable sequence type, as documented in ranges and sequence types, list, tuples, and ranges. You don't have to know what that means because I don't either. So again, using a for loop, range 5, I'll print out the value of x, so every x in that range 5. I print out 0 through 4. So it's another up to but not including. You can think of it as give me 5 numbers, always starting at 0. There's a second parameter. You can start at a number and end at another number, again exclusive. So I can start at 3, up to but not including 9, print out 3 through 8 inclusive. The third parameter you can see up here. In Python documentation, you'll see this as how they define functions and whatnot. So this version of the function takes a parameter stop, meaning starting at 0, you stop before you get to this number. The second version of that function says start here and stop before you get here. And then we have a step. So the default step value, anybody want to guess? I got one chat guess. The default value is 1. So every time I print out another number, it's incremented by 1. If you pass in that third or optional value, it'll increment by whatever you pass in. So you can pass in 2, 3, 4, 10, whatever, doesn't matter. And every number that comes out will be the last number plus your step. I didn't show that here, but it's pretty straightforward. And then just to show you something, another kind of magic function in Python, I didn't know what an immutable sequence type is either, like academically. And so, but reading that, I knew it was something that was not a list or something that we were used to. And so what I tried to do was assign it to a variable instead of putting it in a for loop. So I called the range function with 10 as a value, assigned it to x. Then there's a magic top level global function called type, which tells you the data type of that variable at that point in time. So I pass in type of X and I get a class of range. Cool. There is a list function that takes in any object, but in this case, when that list takes in a range class, an object of class range, it's going to return it as a list. So I'm not going to say typecast, I have converted that range class to a list class by calling that list function. So the list function converts whatever comes into it into a list. And so by calling that, again, magic type function, I can see that now I have a class list, and I can do all the list things on that class. So one of the things you have to determine, or will determine over time, is when do I use the range function in one of those like for loops or counters? When do I want to use it maybe to pre-populate a list? Pay attention to that for your homework, maybe. The slide's kind of important. Cool. Okay. Does that make some sense? You don't have to understand how, why, whatever, but calling the list function with that range output converts it to the list you would expect. So I think if I did that range function and I tried to do one of the sorting functions at the end of it, I don't think it would work. But we can figure that out. So I'm trying to follow the book. It will make for a better learning experience because someone spent a year of their life writing that book and putting things in a specific order. And the reason I tell you that is when I saw list comprehension in chapter 3, as a Python developer of 15 years, that kind of blew my mind. I was like, what? I don't even get it. I get it, but anyway, but then I had a funny comment in here that says, list comprehensions are not always presented to beginners, but I have included them here because you'll likely see them as soon as you start looking at other people's code. And I was like, okay, that's good enough reason just to show the syntax of what it means. Ooh, and I didn't break up 2 slides, my bad. So this allows you to perform some actions on a list in one line of code. Kind of combines a for loop in the creation of a new list or new elements in one line of code. And it looks a little funny. So this is list comprehension. Value times 2. Anybody remember what that is?
Exponent.
Yep. So we're squaring value for value in range 1 through 11. What's range 1 through 11? What are the bounds of range 1 through 11? Starting at 1, ending at
10.
10. Yep. So yeah, a couple people were chat privately to me, but I wanted to see if anybody would come up with it. Yep. 1 through 10. So exclusive 11. So if starting at the back of this line of code, range 1 through 11, 1 comma 11, we know will give us essentially a list 1 through 10. For value in, this is our for loop. Right? It looks exactly the same. Nod your heads. Looks the same as a for loop because it is a for loop. But the part to the left of the for loop, this is what always gets in my head of like, no, I don't understand this. All it's doing, this is performing an action on the value in the list. So for the value in the list, perform this action. This action, we're squaring it. But then again, we're bounded by brackets. So what is the output? A list. So one line of code, I've created a list of squared values from 1 through 10 inclusive and ended up in a new list. So that's list comprehension. We will go over that later more, but when you see it, don't be scared by it like I am. This is a simplistic example for the purpose of walking through it, but the general use of this is, instead of range 1 through 11, you'd probably start with a list. However you got it from a database, you got it from somewhere else, so it'll look a little different. But if you look at it and break it down like that, start from the right. This is the beginning thing you're dealing with. You're assigning a value to it, then you're performing an action on that value. So that's list comprehension. So what I wanted to do now was look at some online Python compiler, some Python online, because there were a lot of things I said, I don't know what would happen, let's figure it out. And this is how I figured it out. So I think one of the first ones was sorting a list. So let's make a list of numbers. Now I can do it really, really quickly because it's cool. Range 1 through 11. I'm going to print to be lazy, but that's not a habit you should get in. So I should get 1 through 10 at the bottom. Is that too small? It feels small to me, but I tried. I don't think I can make that bottom one much bigger. Okay, that works. All right, cool. So let's reverse it. Numbers.reverse. Okay. Now let's sort it. And we're sorted back to how we were. Cool. But what I want to do here, we said what would happen if it has strings in it. Anybody remember how I add something to it? What's the function? At the end. Append. Let's append a string. Numbers.append another string. Okay, so now that's my last. I have my sorted 1 through 10. Then I added a string, z string. Now I'm curious what happens if I print sorted numbers. Notice now I'm using the global function intentionally, just to show two things. That doesn't work. So now we know what happened. You can't compare a string to a number. Make sense? Is 3 greater than a string? Who knows? Now, if I wanted to alphabetically sort those all as strings, if you have a string in your list, you can't use a sort function. No. That is not true. Numbers equals a string, z string. That was a private Zoom comment that I obfuscated the writer from. So here, let's. Can I just run? I'll run it all. So I'm changing the values in my number string to be 3 strings. It sorted just fine. So why didn't it sort the first time? Why doesn't this work? All right. So this, why did this not sort? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A string, Z string. Anybody? Different data types. Bingo. You can't compare. A sort function compares the value of all the elements to each other. You can't compare a string and an integer. It just does not compute. And so that's what that error message says. Unorderable types. String, integer. You can't compare to find which one is less than the other. So I think I was trying to ask when I was hanging up, how can we compare them all as strings? What tools have we used to convert or to make this possible? Anything? Any ideas? Some hints. I can take a number and turn it into a string by calling a magic global function, str. Not typecasting, but conversion. So now, whoops, what does it not like in my syntax? Invalid syntax.
Line 20, we gotta print that.
Thank you. I would have caught that because it did say line 20 somewhere there. Okay, cool. So now we'll run that. So now when I print out that 3, I'm printing out a string. And just to make sure, I'll use that type function again, just to make sure it is a string and it is of class string. Okay, so I know I can convert my numbers to a string. Can I convert my strings to a number? No. Who wants to be brave? Anybody want to be brave and figure out some list comprehension with me? List comprehension? All right, we can do it without list comprehension. Can you typecast? No. Not in this case. Let's do a for loop. So if I want an array or a list of all strings, string list equals nothing. How can I put all of those values from my numbers array, which has numbers and strings, into a new array, into a new list? This is where we start using multiple things we've learned about and kind of combining them into one. So I want to take all the elements in my numbers array, my numbers list. I gotta stop saying array. I want to take each element in my numbers list, convert it to a string, and put it in my string list. And then I want to sort my string list. So how do I do that? First suggestion. Is to use that string function, pass in the numbers list, and get an output from that. Anybody want to guess what that output will be? I can tell you it is not a list of strings. What was the output of that str function when I called it up here? And I like the guesses, even if they're not right, because it allows us to go through this. So never feel bad or worry about saying the wrong thing, please. I'd much rather have class participation than silence like we're getting now. Somebody's got to guess. Pretty please. Jaleel, you are correct. I will get a string out of that. So when I run that, oops, I need to move that. No, go away. So when I run that, I get a string. Now, it prints out the same, kind of. It printed out a string, and in that string was the thing that looks like a list, but it's really a string. So that's close. What is the one control structure we learned today? Thank you, Raymond. A for loop. If we were in a classroom, I could throw things at y'all, but I'm not allowed to do that here. So we did a for loop. So for, let's call it item in what? For item in numbers. I want to make it a string. How would I make it a string?
The string function str.
Thank you. Then what do I do with that string item? Then I append it. Yes, string list dot append string item. Now I can print out my string list, and we should see a pretty list of a whole bunch of strings. So if you look at the last two lines, you'll see the first one has a bunch of numbers, integers, and then two strings. The last line has a whole bunch of strings, and you can tell that because they all have the quotes around them. Now I want to sort them. So let's print sorted list. Nope, not list, string list. Now they are sorted alphabetically, not numerically. And that is what we were going for, so that's cool. Now let's figure it out with list comprehension. All we're doing is combining all that kind of stuff into one line of code. So I know my output is going to be a string list. You remember the syntax here? We'll use this as a reference. So we'll use that as a reference. Where do I start? Let's start at the back. So instead of range 1 through 11, what is the list we will be comprehensioning? The list we will be traversing? Numbers. Yep. Okay, so we'll be traversing numbers. And then going to the left, for value in. Okay, cool. So we're doing another for loop item in for item in numbers. Okay. What are we doing to item? String. Yep. String. item. Now we're missing one thing, two things. What are we missing? Range? Nope, we're not ranging. Yes, Raymond, the brackets. End bracket, start bracket. Now I can print my string list. And just to print it twice, put a little helping code in there. Congratulations, we have just list comprehensioned. So this one line of code is the same as 4 lines of code. And for this straightforward example, I don't think that's harder to read. Does anyone think that's harder to read? Yes is an acceptable answer. I got a no. There are 27 others of y'all. Easier to read, harder to read? Easier, no, easier, okay. Similar to C#. See, I don't know C# much. See, this is interaction. I like this, thank you. Normally I would just point at you and yell at you and stuff, but it's really hard to do online. Okay, cool. So that is, the list comprehension is one of the harder things in Python to understand. And actually now having gone through this with you guys, I think the author of the book might have been onto something, starting with a good, simple example. Because after this, you know we can change it. So if I change this to be a function call that returns a list or returns an iterator or something else, you know, we can use that. And it's just building on this basic construct. Super cool. The list comprehension is in using the old other way. Okay. So yeah, the one comment in there was the older way of doing it was confusing. So this was the confusing part. I've taught C++ to this course for the past 4 semesters, 3-4 semesters, and we can only do it this way. And so I'm very appreciative of the new way of doing things. So I'm much, much happier about that. All right. And now we can read it. Okay, cool. So this should be a trial for a whole bunch of different things. So first, I'm going to make sure you have your GitHub repo working. I'm going to make sure you can figure out how to get code into GitHub. You can go back to last week's slides to help you with that. And then the code I want you to write is going to be in a function, but don't think about the function. Just write the code. So I've created a function called squared threes. I don't know why. This is going to be the structure of your code. So when your homework.py file is in GitHub, it will have all of this code plus whatever code you put in here between these two comments. So what I need is when this program runs, I want it to print out the squared value of every number between 0 and 99 inclusive that is evenly divisible by 3. So the first 3 of those numbers should be 9, 36, 81, etc., 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 until we get to 99 squared, which I couldn't do in my head. The way to accomplish that, you will have an empty list to start. The function will return whatever you put in that list, and then my code will print out every value. Are the instructions clear enough?
Yes.
One yes, one yeah, yes, yes, yes. Feel free to ask me any questions you want about this. I don't care how you do it. short of hard coding the answers. You can't do that. That's not allowed. You have to use the structures and the functions we used. Whether you use list, comprehension, or not, doesn't matter to me. But you will probably use the range function. You might not. You will use a for loop, probably. So there are things that we have talked about that you will use. Only use things that we have talked about. Don't find some cool Python function that does this work for you. This will be due next Wednesday by midnight, so you have 6.5 days to do it. My grading policy is if it is late, you have a week, and after the due date, you will immediately lose 50% of the grade you should have gotten. So if you did a perfect job, but it's a minute late, and I can use GitHub timestamps for that, you'll get a 50%. But if it's on time and you did awesome, you'll get 100%. But if it's more than a week late, I will not accept it. You will get a 0. Clear?
Yes.
Question, are we allowed to work with others in this class on these homework assignments or not? Not yet. Or no. That's a better answer. No. There might be a time in the future where I'm like, this is a hard homework. Maybe you can pair off, but not yet. Nope. All right, well, that is the class content for the evening. Only half the time. Dang, I need to throw in more material every week. Y'all don't laugh at my jokes. I guess I'm not funny. That's okay. I'm okay with that. I got kids. They yell at me because I'm stupid. All right, cool. Well, I will stick around until the last one of y'all leaves.